Okay, now there we have the equation in which methane is reacting with chlorine and providing you methyl chloride, and we have hydrochloric acid. And what we have to do here, then you have to draw the diagram for the pathway of the reaction and label it its axis, reactant, product, enthalpy change of reaction, and activation energy. As we know, the reaction, it is mentioned here that the reaction is exothermic, so that means the heat is released from the system. So when heat is released, that means the product will be at low, um, you know, its energy level is low as compared to reactant. So the straight line of reactant, and then the particles collide and they cross the activation energy, and then the energy drops and the product is formed. So potential energy on your y-axis, reaction pathway is showing on your x-axis. The activation energy, that is the gap from reactant to the top, that is activation energy, and from the reactant to product, the change is considered as enthalpy change. So all of that things are mentioned here, that we can see it clearly, right? Okay, so then the next part here is, okay, there we have the B part. Hydrogen iodide decomposes to make hydrogen and iodine, and we have to calculate the enthalpy change of the reaction, and we have all of the bond energies are given here. So there we have the systematic procedure to determine it. You have to calculate the total energy required to break the bond, and there are two hydrogen iodide bond energy, so you have to multiply it with 2, the value given. Then calculate the total energy released when the bond is the product is formed. So here we have hydrogen to hydrogen bond, iodine to iodine bond. So then you have to calculate it, add it, you will get the energy. To calculate the enthalpy change of the reaction, enthalpy change, the energy required to break bond minus the energy released. So you just subtract it and you will get 9 kilojoule per mole. So that is the energy change which happened here. Then moving on to the next question. The question is methanol and propane 1-all and propane 2-all are alcohols. The displayed formula of methanol and propane 1-all, they are given to you. State the general formula of the homologous series of alcohols. So okay, there we have for the general formula, if you talk about your the difference between alkane and alcohol is the only one hydrogen is replaced by hydroxyl group. So the formula for alkane is CnH2n plus 2. So here we have just switch that one hydrogen, so it becomes CnH2n plus 1 and OH. So that is general formula. Propane 1-ol and propane 2-ol have the same molecular formula but different structural formula. State the name given to the compounds that have the same molecular but different structural formula. They are called as structural isomers. Then draw the structural formula of propane 2-ol. In propane, we have 3 carbons, so you have to draw 3 carbons, and all of this valencies is satisfied with hydrogen except the central carbon, is one hydrogen, and one is satisfied with hydroxyl group. OH group is there. State why propane 1-ol is a saturated compound. After drawing the structure, you can clearly see that all of the bonds are single bonds, so then that is a saturated compound. State why propane 1-ol is not a hydrocarbon, because it has oxygen with addition of hydrogen and carbon, so that is why. Then propane 1-ol reacts in the same way as ethanol. Draw the displayed formula of the product of the reaction of propane 1-ol with acidified aqueous potassium manganate. When we reacted with it, ol converted it to OH, so the OH group gives you propane gives you propanoic acid. So the next one is draw the displayed formula of the product of the reaction. Propane 1-ol and ethanoic acid is reacting. If it reacts, then it forms the propyl ethanoate acid. And here we have the structures for both of these, which you need to draw. Here we have the structures. There we have. So these two structures for the first and second question. So the in case of propanol, we get converted into propanoic acid, and on the other hand, when it reacts with ethanol and it's simple propanoic, it is converted into propyl ethanoate. Okay, then we have the next question. Methanol is a covalent substance. Draw a dot and cross diagram to show the bonding in a molecule for methanol include only the outer shell electrons of each atom. So just we have methanol. So two carbons are here and five hydrogens and one hydroxyl. So each one carbon with all three hydrogens and the other one two hydrogen and one hydroxyl group. And you just need to put dot and cross instead of the line of the bond. So then the next state, sorry, it's methanol, not ethanol. So methanol only contain one carbon. So we have carbon, three hydrogens, and OH group. So just instead of drawing the bond, the line, you have to draw dot and cross. State why methanol does not conduct electricity. Obviously, methanol doesn't conduct electricity because it doesn't have free electrons. The electrons are engaged in bonding. Methanol is used as a solvent. State the meaning of the term solvent. Solvent is that type of substance which have an ability to dissolve other substances in it. And so that's why methanol is acting as a solvent, or you can simply state that solvent is a material which have an ability to dissolve solute in it. So methanol is acting as a solvent. So there we have the only two questions from paper 2 variant 1.